And let's start with, I don't know, a query. Let's see that we want to find out every animal's most recent vaccination. So let me show you the tables that are involved. We have the vaccinations table, which includes the animal, which is identified by name and species, the vaccination type, the type of the vaccine, batch comments, and the email, which identifies the staff person who performed the vaccination. Okay, so that will be one table that will be involved. And the second table, animals. This is the animals table. Again, the identifier is name and species. So every animal's identifier is name and species, got a primary color, a breed, which could be a null for non-purebred animals, or an actual breed, gender, birth date, color pattern, and admission date. Let's say that I need to retrieve an animal's attributes, and alongside, next to each animal, I want to have another column here, which will be, I'm just putting a null placeholder, it's going to be as latest vaccination. And all I'm interested in knowing is what vaccination name. What vaccination was the latest that this animal has received? Remember, the vaccinations, we got the animal name, again, the identifier, that's the primary key of animals. The primary key of vaccinations is name, species, and vaccination time. And I need to fetch the vaccine column from here, and I need to get all the animal attributes. So how would you go about answering this type of question?
With a join.
You can join. Okay, so we can do a join between animals and vaccinations based on the animal.
Actually, I wouldn't do it with a join. I wouldn't do it with a join. I would just say, I would list both tables in the from, and then say where vaccinations dot animal ID equals animals dot animal ID, and not use the word join at all.
You said a couple of things that I want to address. The first one is no matter what the syntax that you use, a join is still a join. So if I use from animals and spell inner join vaccinations and then spell the on clause, that's an inner join. If I write animals, comma, vaccinations, and say where animals dot identifier, and that will be the second part of the discussion here. The short discussion we're going to have. Animals dot, let's say, name equals vaccination dot name, etc., right?
So I find that a much easier syntax.
Okay, this syntax with a comma has been deprecated in ANSI SQL 92. ANSI SQL 92 was 28 years ago. And there's a very good reason why it was deprecated, and you should not use it. You know, if you still are handling old code of people that still wrote it this way, or it's been written many years ago, be familiar with it. But if you write new code, never use this syntax. And we actually have, I think, about a 15 or 20-minute discussion either in part 1 or in part 2. So I recommend that you go watch them, which explain the difference, the logical difference between specifying the join predicate as part of the where clause versus specifying it as part of the from clause. And I'll just give you a hint that as far as inner joins are concerned, it's not a big deal. But as far as outer joins are concerned, it could be a huge deal. Don't use the comma-separated syntax, number one. Number 2, your initial assumption was that there was some kind of animal ID that we use to join between the tables. Unfortunately, this is something that I see more often than not, that people take for granted that every row in the database must have some sort of row pointer, GUID, enumerator, whatever, and should be used as the primary key. If I had to point out a single habit that I believe to be the most disastrous for every database design, that would be it. I think we also, if you go back to the meetup, we had several sessions on the topic of primary keys. So I invite you to watch these as well. And if you can't find them, I don't know, maybe they're old, we can do another one. Or if you look on YouTube, there's one that I did for Code Camp that you can also watch. So it's a full hour about why using IDs is not always a good idea, pun intended. For our purposes, just be aware that there is no animal ID. The animal is identified here by its name and species, and this is a business decision. Okay, there's nothing wrong or bad with not being able to have two animals of the same species with the same name. That's a business decision. That's what the business uses to identify animals. It's my business, so I decided it. That's why this is the business key, and the business key is what should be used in most cases as the primary key of the table. And I recently had a discussion, you know what, while we're at it, and since we're having kind of a free night tonight, right? There's nothing that I really need to finish. I do want to point out one very important logical distinction, which a lot of people seem to not get, but let's try it. Let's try this. Okay, so let's say create table. Let's call it TID. Okay, that will be a person. That will be, you know what? Let's call it persons, and this will be persons underscore identifier. It will have a person ID, which would be an integer, identity, 1, and it will have a first name, which is, you know what, let's do first name, which will be a varchar, I don't know, 10 will be enough for us, and a last name, which will be varchar 10 as well. Does this design make sense?
Yes.
Does this design make sense to everybody as a persons table? Yes, no, maybe? You can unmute yourself. There's not a lot of us today. I think there are about 20, 22 people. So as long as you remember to unmute yourself afterwards. So that's a valid table design, right? Okay, so now I'm going to offer an alternative design, hold on, in which there is no identity. The primary key is first name, last name. And this will be person. Does this design make sense?
Might be better off have something more than just first name and last name.
Why?
Okay.
Because
so you think
you can always find a John Smith, multiple John Smith.
Right.
Excellent example. Thank you. So let's put John Smith, and so we'll do insert into person's ID, John and Smith, and then we'll have another one for Jane Doe, and we'll have another John Smith. So let me create these two tables. Let me just switch to tempdb. So let's create these two tables. And now if I insert into persons the one with the ID, no problem. We get 3 rows affected, right? Everything ran great. And now if I run this, I get an error which says violation of primary key constraint, cannot insert duplicate key and object, duplicate value is John Smith, right? So what you're saying, and correct me if I'm wrong, is that this design is better because it allowed me to put in 2 John Smiths, right? So I can have customers with the same first name and last name, and the only thing that identifies them is this thing that we call an ID, right? So here, what's the problem, right? We have 1 John Smith with an ID of 1, and one John Smith with the ID of 4, right? Everything's great, no problem. We can identify our customers, right? Or can we?
Which John Smith is which? You need more information, more real information about them. I mean,
You would need another identifier because otherwise you've got 2 duplicate rows just looking at the screen.
their phone number.
But wasn't that what you said? That if I have a person ID, I can put in more people, more than one person by the name of John Smith? Wasn't that the original reason that you said that we should use an ID here?
You would have more information about them.
Okay, so give me an example of more information.
Phone number, address, age.
Phone
Something
number, address, age.
You-
Okay, okay.
You wouldn't use age because that could be the same as well. You want to use something that would be unique.
That would be unique. Okay, so what would be unique?
Phone number.
Phone number would be unique. Okay, so what you're saying here is that let's, for example, drop table person's ID and person's NK. Okay, let's drop these 2 tables. And now I'm going to add here phone. And that's going to be varchar 11. And I'm going to come back here. And I'm going to say I'm going to add the phone here too. And here I'm going to add it to the primary key. Okay? Now let's go back here and say John Smith 1, 2, 3, 4. Jane Doe 5, 6, 7, 8. And here, let's take this, copy it here, take this, copy it here. And now what I'm going to do,
You put it on the wrong one.
I'm going to be a wise guy. Hold on. I'm going to try and put John Smith with the same phone number. Let's create these 2 tables. Did I drop these? Yes, I did. Let's create these 2, one with the ID and one without. And let's try to insert here. So here I insert, no problem, 3 rows affected. Here, I try to insert, what do I get? Violation of primary key constraint. Which one is the more correct design?
Second one, NK.
Why?
Because you should not be able to insert 2 John Smiths with the same phone number.
Correct. The ID that you add and use as a primary key identifies a row in a table. But a row in a table represents something out in the real world. It could be a person, it could be a product, it could be anything. But the database is always a model of reality. And so in order to be able to identify not the row in the table is just a tool. We don't care if it's rows or if we put it, I don't know, in another type of database. We want to be able to identify the person. And in order to identify the person, we need to know what the business out there in the real world uses to identify that person. And it could be that for one business, if it's a local grocery shop where its only shoppers are from 3 blocks away, maybe first name and last name is good enough. Maybe they don't have or don't care to have more than 2 customers with the same first name and last name. For Bank of America, this would probably be a less suitable key, right? But it depends on the business. And now if I go back to our animals, and now when I say that it was the business key, this is the way the shelter staff identify animals. They identify animals by name and species. And because they do that, that is the primary key. That is the main identifier for an animal. And that also means that for a vaccination, the identifier is, God forbid, now all these three columns, because it's the animal and the vaccination time, because you cannot vaccinate an animal for two vaccinations at the same time, unless you're using a hybrid vaccine or something, but I didn't want to go that far.
Why didn't you want to use their microchip? Wouldn't that be unique?
Very good. So the microchip would actually be very unique, and it would actually be the most natural key for that particular animal. The problem is, first of all, not all animals are necessarily chipped, but even if we assume that any animal that comes in to our shelter immediately gets chipped, then what you want to do is you want to choose, since now we have a choice between several options, several identifiers, one of them being name and species, which is unique, and the other one being implant chip ID, which is also unique. Now we need to choose between these two. These are called candidate keys. These are two different attributes that can identify an animal. So two different sets of attributes that can identify an animal. And then we come, okay, so if we need to choose between more than one potential key, we typically want to choose, there are additional criteria. You want to choose something that is stable. And in this case, both the species is definitely stable. The name is stable. We don't change the names of our animals. And then, if they get adopted, the new owner can change the name. But implant chip ID is also stable. It doesn't change, right? And then we come to the third desired quality, which is something that is familiar. And the idea here is that if I call you, if Abby the dog just escaped her room and she's running down the corridor, I doubt that you will start shouting, hey, FD6FE334748E08C is running down the corridor, right?
So that's irrelevant, what you would call the dog in person.
That's what is more familiar to the business. This is what our staff uses to communicate when they need to identify an animal. So if I need to identify an animal, I will say April the rabbit. If I need to call the vet and tell him, hey, April the rabbit is not feeling good, I can say, hey, animal with implant chip CCFEF7E8 is not feeling well, right? I can do that.
No,
But
because
that would probably...
in your front end, you would use the name. In your back end, you would convert that to the ID.
Why?
Because the name is risky. Using the name, you could have two dogs named Abby.
No, I cannot.
Okay.
Because the database is going, once I use that as my primary key, I will not be able, that was the business decision.
Okay.
Remember, this has nothing to do with the database. It's exactly the same idea here, that with a person, if first name and last name is enough to identify a person, that means that is his key. And if you need to add additional attributes like email or phone or whatever, great, then that is your key. This is what your business uses in order to identify a person. And if you have more than one key, and there are plenty of examples of entities that have more than one key. One of the most common ones, for example, you can take countries, for example. Okay, a country, almost all of its attributes are unique. And still, you will need to choose one of them as the primary key. But that would be one of the identifying attributes, one of the... Anyway, I hope it makes a little sense.
Amy, I have a quick question. Yeah, one question.
Yes.
So you said that it's not a good idea to use ID as a primary key, right? Say, suppose we
No,
have a lookup. Yeah.
I said it's not a primary key.
No, like
A
I just want to.
primary key, by definition,
Uh-huh.
you can go and check COD's work, is the set of attributes. It's one of the sets of attributes that uniquely identify the entity. Person ID does not identify the entity. Person ID identifies a row in the table. But if you have two people who are named John Smith, person and they both walk in, okay? So now let's say you have a shop and somebody walks in and says, hey, I'm John Smith. and you go to your table and you look it up. So you bring up your interface and you look at it and you say, oh, I see. But hold on, are you John Smith with ID number 1 or are you John Smith with ID number 3?
3, okay.
What do you think the customer is going to say? He's going to turn around, think you're crazy, and walk away, right? Because person ID, it's not an attribute of the person. It's an attribute of the row in the database, but without a logical context, it is completely meaningless.
Yeah, I get that. I just have a quick question. So suppose we have a lookup table, like say status table, right?
There is no such thing as a lookup table. You're
Oh.
welcome to go back to COD's work and check the term lookup table doesn't appear.
Okay.
There is no such thing. So what you do want to do, and this is what we do, for example, here with animals. So there's the animals table.
Okay.
Okay, and the animals table has name and species. And what we do have another table, which is called select star from reference dot species. We have a table, which I put in a special schema called it reference.
Okay.
And all this table has is a single column called species, which holds a fact about the universe. These are the species that we have, that we are allowed to take into our shelter. But that's the primary key, the species. This means that I cannot put the same species more than once. There is no ID.
Right.
You don't need it.
Okay.
And from animals, what you're going to do is you're going to reference this species column to the species table that you just saw. And this will guarantee that you can only put species that are part of your data universe.
Okay.
And this will be true for countries, addresses. I don't know if you want to do it for names or whatever other entity, which you can have external data, because species is not data that I invented, right? Species is a scientific designation of animals based on, what is it called? There's a name for it. I recently found it out. The classification of animals. There's a name for that. I forgot. Anyway, this should be your real, what do you call, lookup table. It's not a lookup. You don't have to look up anything.
Right,
This
right.
simply represents the fact that these are the species that we can allow in our shelter. And that means that these are the only animals will be allowed from these species. And if you try to put an elephant in, you're going to get an error.
Okay.
Okay?
Yeah. Okay. Thank you.
Okay. Any more questions about this? Does this make sense? Do you see why the ID doesn't identify anything? It's not a key.
If you have, so you can't, if you have like 2 or more dogs with the same name, you gotta change your primary key then.
If I got what?
If you have 2 or more dogs with the same name, you have to modify your primary key. You gotta add more.
No. It works the other way around. The database doesn't determine reality. Reality determines the database. If you have a business, and this is what your business uses, it uses first name and last name. If tomorrow the business changes and the change requires, I don't know, adding phone, that's legitimate, no problem. But that means that the business itself, the universe out there has changed. The same grocery store that used to use only first name and last name now has expanded, it changed the business model, and now it wants to allow more. Then in that case, yes, I will need to change it. And by the way, that wouldn't be that difficult. But with persons, it's a little bit tricky. Persons is actually maybe not the best example, although it's very familiar. It's one of the harder things is actually to identify a person. because there are very few natural keys for it. You can think of things like DNA or retina scan or fingerprint. All these would be natural keys for a human. But even if you look at things like SSN, that kind of limits you because not everybody in the United States, for example, has a social security number, et cetera, et cetera. But that's a business problem. That's not a database problem. So I can tell you, for example, that academic institutes across most academic institutes, to identify students, they use first name, last name, and date of birth. And does that mean that you cannot have it happen once in a million years that first name, last name, and date of birth happen to be the same? Well, if that's the case, that's a business problem. That's not the database problem. The person who is in charge of the data model for the university should decide whether or not they want to change the key. But having person ID doesn't solve that problem. Because if you can still have multiple, what was the name that we used, John Smith, and the person ID is not going to be able to let you tell them apart. Yes, it will let you tell the rows apart in the database, but the rows, you won't know which one is pointing to which of your customers. So it's completely meaningless. Logically, it's completely meaningless. You think it gives you uniqueness, but it doesn't, which is even worse. But anyway, enough of that. Oh, we wanted to show the latest vaccination. So we started with, I don't remember who it was that offered to do a join, which, a valid solution. You want to walk me through it? We can try to solve it here. Anybody want to walk me through the solution using a join?
You mean like use left outer join?
We can try. So let's say animals as A. If we do inner join vaccinations as B, on A dot name equals B dot name, and A dot species equals, let's call it V. Not species, not B. Let's call it V for vaccination. And by the way, now you can see when you use the natural key, you can immediately see what identifies an animal. You can see that its name is species just by looking at the query. Right? You don't have to go and figure out which attributes are unique. You know what is unique. What's the problem with this approach? So, we have count star from animals. We have 100 animals, and we have 95 vaccinations. So not all animals were vaccinated, and since we have animals that were vaccinated more than once, that means that there are even fewer than 5 that were not vaccinated. So what's the problem with this approach? If I want to get the latest vaccination, what was the latest vaccination?
Some of your animals will be missing, so you need to make it a join. I don't know if it's the left, right, outer, not inner.
Left
Okay,
outer
right.
join.
Correct. This will eliminate animals that were not vaccinated, and in order to get them back, we will need to do a left outer join, right?
Some animals might be vaccinated more than one time.
You
Right.
can get
So
it with left outer join.
what do I get now? So how do I get the latest vaccination? Now I have each animal with all its vaccination.
Max, you want to get the most recent vaccination time. So you would use the max function on vaccination time, and then this would become an aggregate function, I believe.
Okay, so you want to use max? Just guide me through it. Max what?
I'm not sure I'm qualified, but max vaccination time.
Max vaccination time. Okay.
I think you need to group, I think, on animals, on the animals table.
Right. Okay. So let's make it so that we don't have to do anything. Let's take just species. Let's take a name, color. Okay, primary color. So you're absolutely correct that since this is an aggregate function and I want to be able to get the maximum vaccination time per group, right? So what would I group by?
PC name and color.
Yep. No color.
A
Oh,
species,
yeah, color.
If it's in the field, you have to have it.
Yeah.
a name. So remember, I want to get back a single row per animal, right? So I need to group by the animal identifier. So if I group by species and name, that guarantees that I'm going to get one row per animal. However, this is going to throw a syntax error. It's not a syntax, it's an invalid error.
Right, because you don't have
Because
Primary
color.
color.
primary color, correct. So what can I do about that?
You can do a max on primary color, or you can include primary color in your group by.
Yeah.
Correct. So I can add an aggregate function, which really doesn't do anything. It's going to be a dummy aggregate function. And you know why it's going to be a dummy aggregate function? Because all animals has only one color. So Abby the dog, no matter how many vaccinations she had, she was always black. And the reason is, the technical reason is that primary color is functionally dependent on name and species, meaning that name and species determines the primary color. And that's why we're guaranteed for all primary colors within a group of species and name to be the exact same value. So you can either do it like that, by the way, which I like it less. I think it makes the query less readable. But another option would be to put here a max or a min. It doesn't really matter.
That's awful.
I usually like to put a comment that this is a dummy aggregate. Okay?
Terrible.
So interestingly enough, the ANSI SQL standard did come up with a solution for this. So there's a feature called T301, which was suggested, I think, back in the days of SQL 92. And the only database that currently supports it to some degree is MySQL. And in MySQL, it's actually legal to run this query because it supports that feature T301. So if the database can determine that primary color is functionally dependent on the combination of name and species, then this query is valid. There's no logical issue. But the thing is that the database must figure it out. So most databases don't, and SQL Server doesn't, and PostgreSQL, and you're going to get an error. So you can either change the group by or change that, or you can, well, we can do other things. We can put that in a common table expression in a with clause, and then join to get the primary color only later. So there's several ways to go about it. Okay, but by the way, that didn't solve my problem, because what this got you is the latest vaccination time. And if I run this query, what it's going to give us is the latest vaccination time. It doesn't give me the latest vaccination. I want to know if it got a herpes virus or a rabies vaccination, not the latest date. How would you go about that?
Can you repeat the question?
The max of vaccination time returned the latest vaccination time. It didn't return the latest vaccination.
Oh, type.
What
Vaccination.
what I'm interested in is the name of the vaccination that this animal received last. So
Having.
I need the vaccine. You can see here, this guy received 4 vaccinations. They were all distemper. This is when he was very young. You give distemper virus to puppies. I see this, April.
That's
These,
2 dogs,
oh,
by the way.
I want the vaccine name. I don't want the vaccination time. How would you go about that?
Having.
Having. Okay. Having what?
Having, well, you would put the vaccine in your select clause instead of vaccination time.
Here?
No, instead of vaccination time, and take out the max. It would not be, I think it would not be an aggregate. And then your having clause would be having vaccination time equals, this is wrong, but I was going to say having vaccination time equals max vaccination time, but that's wrong. I don't remember how to do it.
How about having max of vaccination time? Oh, wait, that's not it. Never mind. That was the count I was thinking about.
First of all, vaccination here would be, vaccination is not functionally dependent on species and name, because every animal can have multiple vaccinations. And if I group by species and name, meaning I'm going to get one row back per animal, and every animal received potentially more than one type of vaccination, then vaccination as an expression doesn't make sense here without an aggregate function. And if I try to do something like max vaccination, that's going to return the vaccination with what? Vaccine. Sorry, not vaccination, vaccine.
Well, that'll just give you it'll be based on the alphabetic order of the vaccine.
Correct. That will
What
return the vaccine with the highest alphabetic order. So how do we solve this problem?
How
I mean,
about
you could
better way?
concatenate the date onto the vaccination string, the vaccine string, and then order it, then select the right portion of it. That would be
So
complicated though.
We could do what? Can you repeat that? I didn't
You
follow.
could concatenate the date in YYYYMMDD format to the vaccine.
Concatenate the date to the vaccine. The vaccine, okay, so create a larger string, and then what? And then pick it up and break it up again?
Yes, and then do a pull back the right portion of the string minus the length minus what, 8.
So you're concatenating two different attributes just because they happen to be strings.
Well, you have to turn the date into a string. Concatenate to the vaccine. Yeah. I mean, it's a way to get through it. I mean, the better way is probably just to do a window function with a row count and a subquery. But
okay, a window function, but will be a valid solution. But there are much simpler solutions.
I would do it as a simple subquery.
A simple subquery. Okay.
Yeah.
Right. So the maximum of vaccination time is, and get the subquery will be the max of it.
So let's try a different approach. Okay. Remember, I started by giving you a little hint. I put the null as latest vaccination. Do I really need to go through all the trouble of joining each and every animal to its vaccination, get multiple rows per animal, then after that, go back and group back again to get my original animal row, and still it didn't give me the solution it didn't give me the answer that I wanted, even though there is a way to do that here. By the way, what you would need to do is you would need to first find out what is the latest vaccination date for each animal, and then you would go and join back. So let me show you just how to do it with the previous solution. So what I can do is say with animals and latest vaccination date as, and then I will take this thing and wrap it around, and I will put here the vaccination time. Now, if I do a select star from this long name, animals, so this will give me all the animals and their latest vaccination date, right? Now, if you think about it, now you have the primary key for the vaccination table, because this will identify the individual vaccination based on a join by species name and latest vaccination. So now all I got to do is go back here. Let's call it as ALV. And then I'm going to do inner join vaccinations as V on V.name equals ALV dot name, and V dot species equals ALV dot species, and v dot vaccination time equals A of v dot latest vaccination. And now, if we take this whole thing and run it, then we can get back all the original attributes. Each animal appears only once because for each animal there's only one vaccine row that will match this time. So now you can see that we get back, where is it? We get back the 46 rows. These are the animals that were affected. And if I would like to change that, I can do this with the left outer join here too. And that will return, did I do a left outer join here? Yes. So this will bring back each animal only once. And now I get all our 100 animals back. And the result, now you can pick, you get the vaccination time, you get the vaccine name, you get the batch, you get the comment, you get whatever other attribute that you need. But we use the vaccination time to get it, okay? But yeah, I wouldn't recommend going that route. There are much, much simpler ways to do that. And you started on the right track, which was to use a subquery. So how would we go about using a subquery here? Let me call it animals as A.
I'll do it if nobody else wants to.
Yeah, go ahead.
Okay. So let's see. Select
Right. Oops.
Vaccine.
Correct. I like the way you tackle this already.
From what is it called? Vaccinations? Whatever's the name of the table? Vaccinations.
Vaccinations as V. Right.
V. Where V dot. Oh, wait a sec.
No, you're.
But we need to get we still need to get the latest vaccination.
Right. So
I think we want to say I think we want to make this an aggregate function. Say select max vaccination time, comma.
Then you're going back to the same problem we had here.
But I'm putting that in the subquery. Okay, somebody else take over.
Yes, you are putting it in a subquery, but still, here we will get the vaccination time.
Yeah, just say the vaccination time is equal to the max of A vaccination time.
Yeah, so we're going back to the same what we had here. So we're going to have to join back to vaccination based on, but I would like to suggest a different alternative, okay? How about we say order by
top
vaccination time.
Select top
and offset 0 rows, fetch next 1 row.
God.
Only. Right? This is the same as top, but top is a proprietary syntax. And this, funnily enough, this is the official ANSI syntax. And SQL Server is, I think, the only SQL Server in Oracle maybe support the syntax, which is the correct one. All the other databases on the planet use limit offset. So it will be limit 1 offset 0. So if you're using Postgres or MySQL or SQLite or all these guys, you're going to have to write it this way. SQL Server actually supports the full syntax. So, okay. So here we are, and will this give us the correct result? Remember, Abby the dog received a distemper virus, was her latest. Let's check it with a previous query. Let's see if this one returned the same thing. Abby the dog received the distemper virus. That was her latest one. So at least the two queries agree. So this is much simpler, right? This is simpler, more elegant. However, it has two inherent problems. First of all, what happens if I want to return not only the vaccine, but also the vaccination time, or the email of the person who did the vaccine, any of the additional attributes?
You have to do the same thing, but again.
Right. So if I try to do something like vaccine and vaccination time, I'm going to get bit by saying only one expression can be specified in the select list. So this is not going to work. And you are correct. If I want to get the latest vaccination time, I have no choice but to repeat the entire thing once again. And here I'll need to put vaccination time as latest vaccination time. Now, a couple of interesting things happen. First of all, this query becomes completely unreadable, and you can imagine
Yes.
what will happen if you need to retrieve 10 of these attributes. The other thing that happens, and this is also interesting, so if I look at the execution plan, you can see that now we have 3 table accesses. We have 2 accesses to vaccinations and 1 access to animals, which is not the most optimal way to do it. Query optimizers see 2 correlated subqueries. Each one is evaluated as its own branch, meaning that even though both return the same row, right? Both return the same row. The only difference is the attribute that I'm retrieving. Here I'm retrieving vaccine, and here I'm retrieving vaccination time. Multiple attributes, this solution doesn't really work well. The other problem is what happens if instead of retrieving just the latest, I want to retrieve the 3 latest vaccines that this animal has received. Not just one, I want the 3 latest ones. If we try to do something like fetch next 3 rows, you already know that every select expression is evaluated per row, and per animal row, we cannot return 3 rows next to each animal. And this is going to bite me with a slightly different error. Subquery return more than 1 value. This is not permitted, blah, 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 blah. So it's not going to work this way. Moreover, remember that even though the query optimizer is a smart fella, it too has limitations. And the more explicit and simple the query that we write, the easier it becomes for him to do his job. Correlated subqueries, if you remember query processing order, logically are what happens is first the animals table is evaluated in the from clause, then it gets moved to the select, and the select evaluates each expression for each and every row. That means that the subquery is evaluated for each row of animals. And again, logically, it doesn't mean that the database cannot make shortcuts. It can, and sometimes it will, but not always. But there's a way for us, by understanding query processing order and understanding that once it gets to the select, every expression is evaluated per row, we can immediately see that this correlated subquery is going to get evaluated 100 times, once for each animal, logically. Wouldn't it be nice if we could have the set ready-made in the from clause? So, for example, if I want to take this exact same query, animals, cross-join, for each animal, I want you to attach the latest vaccine next to each animal. Wouldn't that be nicer? So for every animal, I want to get the latest vaccine based on vaccination time for that animal. That would be nice, right? Unfortunately, we cannot do that. Do you know why we cannot do that? If I run this query, it's going to give me an incorrect syntax. Let me just make sure that my incorrect syntax is not because something else. Yes, it is because something else, as let's call it latest vaccination. A name and a species could not be bound. Have you seen this error before?
Binding has to do with joins, right?
Binding has to do with figuring out what an expression really means, where to retrieve it from. It's not necessarily for joins. It's anywhere where we use. And you can see there's the red squiggly line on a name and a species. And if I hover over it, it immediately tells me that the multiple part identifier could not be bound. And the reason is that the entire join is evaluated all at once, meaning you cannot have references between two members of the join. There's no problem if without a reference. So let's say if I want to get the latest vaccine like this will work. No problem. But what am I doing? I'm attaching the latest vaccine regardless of animal to all animals. So you can see here that we get the same vaccine, which happens to be the last vaccine in the shelter, but it's not specific to an animal. And if I wanted to get it specific for an animal, I have to limit it only to the animal with the same name and the same species, and that would get the latest vaccine for that animal. However, as I said, unfortunately, this doesn't work because every expression, every table expression in the from clause must be self-sustained. It must stand in its own right, and we cannot use correlations between different table expression which are part of the same join. However, and I'm going to switch to Postgres for a second, and I'm going to run the same query with Postgres. The only difference is that with Postgres, I'm going to have to use this syntax. Invalid reference to from clause. Oh, yeah, invalid to from clause from table A. So you can see the Postgres gave us basically the same error, but it was a little more concise. It says an invalid reference. You cannot reference A within this subquery because it doesn't exist within the scope of the subquery. The ANSI committee quickly realized that this is a limitation that can be easily overcome. And the way that they suggested to do that is simply by adding the keyword lateral. And if I now take this and all I do is add the word lateral after the join and I run the same query, now everything runs as expected and we get the results that we want back. So now we can see Abby got the distemper, but another interesting thing happened along the way. If you look, you can see that instead of all 100 animals, we only get 46 rows back now. Remember what 46 represents?
Number of vaccinations.
Number of animals that were vaccinated.
Right.
Not the number. There were 95 vaccinations, but
the number of matches.
The idea here is that cross-join lateral, which is the ANSI correct syntax, the cross-join lateral eliminates every animal for which the subquery doesn't produce a result. And for animals that were not vaccinated, this is not going to give us back any results, right? So that means that these animals are eliminated. And how do we, and if we want to get animals that were not vaccinated as well, what do we need to do? Outer join, right? But unfortunately, there's no outer cross join. So what we need to say is outer left join lateral. Okay. And if I try to run this, now I'm going to get a syntax error. Why? Because outer joins require a qualification predicate. The syntax for inner join, left outer join, sorry, it's left outer join, not outer left join. Let's just make sure that this is the correct error. This is, that's a nice one. This is the correct error. Yeah. Okay, this is the correct error. Syntax error near or at this guy. The reason being that a left outer join, which designates the animals table as reserved, the syntax itself for all outer and inner joins requires that we have an on clause. And what is the on clause here? What is the condition based on which, what is the qualification predicate? So when we do joins not to a query, but we do a join between animals and vaccinations, we determine, let me write this down.
Would you just do on 1 equals 1?
Yeah, that's very good. I like the way you think. You're almost there. Let's say we do left outer join vaccinations as V. Since the outer join returns rows from the reserved tables that didn't have a match, it only makes sense when there's a match predicate. And in this case, it will be on A dot name equals V dot name and A dot species equal V dot species, right? And any animal who doesn't have a match in vaccination based on these attributes is still going to get returned because of the left outer join. The problem here is that the matching of the animals was not done as part of the join. It's actually done here. This is where we match the row that we return from vaccinations to the row that we want for the same animal. And you were correct when you suggested that what we really need is a condition that is always true. And that means that by default, remember processing order. First, the cross join is evaluated, only then, and the inner join, and only then the outer. In this case, what we really want is for all animals to return, for those which the subquery didn't return at least one row. And in SQL, you write 1 by 1, 1 equals 1. But in PostgreSQL, you simply write true, because Postgres supports a Boolean type, and this is a Boolean type. And SQL Server, unfortunately, doesn't support Boolean types. And this may be one of the reasons that SQL Server decided not to implement lateral joins this way. In SQL Server, instead of cross-join, they decided to call this operation by a different name, and they simply call it cross-apply. But cross-apply is a lateral join. And it comes in 2 flavors. There's a cross-apply, which allows us to do that, and now we get the correct result. But that, too, returns only 46 rows. If we want to get the other ones, we need to use outer apply. And with outer apply, we still get the correct result. And now we get also all the animals that were never vaccinated. We get all our 100 rows back. And the only difference is that when you write the join syntax, you got to provide an on predicate. And with the SQL Server syntax, the outer apply and the cross apply, simply you can go without the on. And therefore, I believe this is part of the reason that they chose this weird outer apply and cross apply when there's a perfectly valid ANSI syntax. But yeah, it's my guess is as good as yours. And now with the outer apply or with the join, it doesn't really matter. Now all the problems that we had before go away, because now nothing prevents me from getting the vaccination time and getting the email. Now I can easily get as many attributes as I want without repeating the whole subquery 100 times. Moreover, nothing prevents me from getting the latest 3 because they're simply going to be joined back to animals. But instead of returning 1 row, we're going to get 3 rows. And now you can see if we go to the messages, you can see that we have 138. And the reason we don't have 3 times is simply some animals were not vaccinated 3 times. And these are lateral join. And let's take a look at the execution plan for a minute. And here you can see that unlike the previous one, we get 1 scan on animals and 1 seek on vaccinations per animal row, but without a 3rd access, which happened originally when we had to use multiple subqueries in the select list. So this has the potential to perform better as well.
No, what happens if you change the select to do a top one there and take out the offset?
In SQL Server, it won't matter. Postgres doesn't support tops. Postgres supports only this. But I highly recommend that, if you got a choice, you'll probably want to use the standard syntax. Not only that, top doesn't allow for offset. So
It doesn't
you
allow
cannot
for offset?
top. So I cannot say I want the first row after. So if I want the second row, I can say offset one row and fetch next one row, and that will bring me the second from the latest vaccine. And this is something that you cannot do with top, right? So this will tell me, in this case, for Abby, it was the same distemper virus, but for other animals, it's probably different.
Postgres runs on Azure Data Studio?
Postgres doesn't run on Azure Data Studio. Azure Data Studio has an extension that allows me to connect and issue queries against Postgres. And show you.
You mean like a linked table?
No, it's an extension here. You can see that's the extension. It's a Microsoft extension. You can download it from GitHub. You can download it from here too.
So you're connecting to an external Postgres?
Yes, I have Postgres, an instance of Postgres installed on this machine, yes.
But in that case, you still are restricted to Azure syntax.
This is Postgres. Here, I've used Postgres.
You can use Post. Oh.
I'm not sure I follow.
Okay.
Azure Data Studio runs locally. It has nothing to do with Azure.
Runs locally.
Azure Data Studio runs locally. It's a local client.
Thank you.
You install it locally, it runs locally, it has nothing to do with Azure, except for the marketing name. But it's a cool utility. I like it. I like it better especially when I have to show, I don't have to, but I want to show other databases. So Postgres is usually my first go-to, just because its support of the SQL language is second only to Oracle. It's much, much stronger than SQL Server on the language department. My new favorite. I really like it.
Hey, I mean, we've got about 10 minutes left before we have to wrap it up. So just let me know.
Yes,
Okay.
I know.
Question.
So we got 10 minutes for questions. So we had time to do exactly lateral joins. And we talked a little bit about primary keys and identifying attributes. If you want more, we have all these topics to discuss in future meetings.
Wait.
Yes, questions. Go ahead.
So can you try the following? Just, I'm not going to give you the whole query, just the from clause. From, open paren, select, well, I don't know if we're using which syntax we're using here, but I would do top one from vaccines, order by vaccination time, vaccination date.
Select top one what? Top one.
Top one. Can we do top one asterisk?
Yes. Top one asterisk from vaccinations. Yes.
Okay, and then in the outer query, is your animals table. So up above where you
here,
have.
So you want to join it to animals?
Exactly, and that would be an inner join.
As a inner join on what? On a dot species equals x dot species and a dot name equals x dot name. Okay. Is this the query that you want?
Well, I'm not sure if it's finished, but that's the general idea.
Okay, so if I run this is going to return only one row.
Okay, we want to get all the rows.
Because
no,
I think I know where you're heading, and let me help you a little, and you tell me if this is if I'm wrong. Okay, so What you're really looking for is to join each animal to the result that finds the latest. Let's say we need the latest vaccination time, just for a second, okay? So what I would do here, instead of top one, I would say select name and species and max
Thank you.
vaccination time from vaccinations group by
Name and species.
name and species. Now I just need to give it an alias. Let's call it latest V.
And order
Okay.
by.
Why do you need an order by?
To get the, oh, you've got max. I'm sorry, you've got max. Great.
So this is going to pre-calculate
Yes.
the maximum vaccine for each animal.
Yes.
Right? Now I can take this, join it back to animals.
Outer.
If I need attributes from animals, but here if it's only name and species is enough, then great. If I need additional attributes from animals, or if I need additional attributes from vaccinations, now I'll have no choice but to also join back to vaccinations. So I'm going to do inner join vaccinations, let's call it V2, on x dot name equals a dot, sorry, V2 dot name, and x dot species equals V2 dot species. And now the last thing, so I don't end up joining back all the vaccinations, now I need to do an x dot latest vaccination equal V2 dot vaccination time. And this, if you remember, this is what we started with here.
Why do you need all that extra, that additional join? I don't understand.
You wanted to get the vaccine back from, so it's not just the vaccination time. You also wanted to get what the vaccination was.
We wanted
So
I mean, one of the problems with this is that there could be two vaccinations given at the same exact time.
So I can tell you that there cannot. In this case, simply because the primary key of vaccinations is name, species, and vaccination time. And again, that was a business decision.
Okay, I missed that.
An
Why
animal,
can't you just put in the inner query, select name, comma species, comma vaccine?
because then you won't be able to group by name and species. You can, because you can have multiple vaccines for the same animal. So
But if you did
do-
a window function there, you could do it with the vaccine.
So this is going to be an invalid query. This is an invalid query because vaccine is not contained in an aggregate function or the group by clause. Our group by here is for name and species. And that means for each name and species, you can have many different vaccines. So which one do you want to return? For the same animal, there could be many vaccines. There could be also many vaccination times, but here you tell it that you want the max. But for vaccine, you remember we couldn't do the max because it would simply pick the one with the highest alphabetical order. So the problem is logic. It's not the problem. You can use all sorts of syntax if you use. By the way, this is my favorite approach, to pre-calculate everything in a group by query and then do a straight up join to it. I think it's much clearer, and in many cases, it's also much more efficient because here we get 46 rows joined to the 100 rows from animals, and that's it. We don't get 100 iterations of the subquery like before. And here, if we, for a minute, avoid this guy, by the way, we can simply avoid this guy. If we don't need anything from animals other than the name and the species, the fact that we used it as the key now means that we don't, not for any table, we're going to have to go for every query, we're going to have to go back to animals to figure out what's the name of the species of the animal ID. Because the animal ID won't interest anyone in the reports, right? The users, they don't care about the animal ID. They want to see name and species. They want to see this is what they use to identify the animal. So the fact that it has ID 1 or ID 50 is completely meaningless. But that also means that for every time you use an ID for a table, that means that every single query in your system is going to have to join back in order to figure out the real attributes, which is what the user is after. The users are not after the ID. The user are not after the country ID or the person ID. They want to see the person SSN. They want to see the person name and address. So by using the natural key, you save yourself huge number of joins. Like you wouldn't believe how many queries that are 30 tables long, all of the sudden become 3 rows with only 2 joins in them, just because the natural key was used throughout, and that means that you don't have to join back to the original table, to the lookup table, right? This is the term that you like to use, lookup table. You don't need it. You don't abstract your actual attributes using an artificial ID. You get your actual attributes, and you can work with them, and you don't have to join back. Well, you will occasionally. If you want to get any attribute which is not name and species, then no choice. You're going to have to join back. But for the most part, and for most queries, that only, in this case, if I want to see vaccinations, I want to see which animal was vaccinated and the vaccination attribute. That's part of the art of choosing. Yes. Okay.
So we have to call it a night.
Awesome. Thank you, everyone.
Okay. Thank you.
Be safe.
Okay. You too. Okay.
Thank you.